All right, picking up right where we left off, and we're at 12H, and we want to write the formula for aluminum nitride. So our aluminum ion is Al3+, and our nitride, that's the name for the nitrogen ion, N3-. Right, so we've got a 3 and a 3. They balance each other out already, so our formula is just AlN. So let's see how we did. All right, continuing on with problem 13. So what is the formula for magnesium phosphate? So we just write our ions. So our magnesium ion is magnesium 2+, and the phosphate ion is PO4 3-. So I'm going to crisscross. So I should have Mg3 PO4 2. PO4 needs to be in parentheses, and that subscript 2 tells us that we have 2 of the PO4s. What is the name for FeClO3 2? So this is our chlorate ion. And chlorate, ClO3, is a 1- ion. And I have 2 of them. So I've got a total of 2 minuses. Right, so if I have one iron, because remember iron is one that can do multiple charges, then that needs to be the iron 2+. Because 2 pluses balance 2 minuses. So our name here needs to include the Roman numeral, so I'll say iron, Roman iron, iron 2 chlorate. Looks like our last choice here. What is the formula for zinc sulfide? So our zinc ion, zinc 2+, and our sulfide ion is zinc S2-. So 2 pluses and 2 minuses, so they balance each other out. So what is the formula for copper 2 nitrate? So remember that Roman numeral 2 tells me that that is copper 2+. And then the formula for our nitrate is NO3 1-. So I have 1 copper and 2 nitrates, so I need my parentheses to say there's 2 of them. Looks like our first choice. So what is our formula for aluminum hydroxide? So our aluminum ion is aluminum 3+, and our hydroxide, excuse me, we're not doing hydroxide, we're just doing oxide. My bad, I misspoke and misread. But the oxide ion is O2-. So I'm going to crisscross, take the 3 and put it with the oxygen, take the 2 and put it with the aluminum. So Al2O3. And our last one on the list here. Right, naming the compound FeCl2. So remember, iron is one of our transition metals that has multiple charges. So I need to pay attention to my anion to figure it out, which one it is. So our chloride, I have 2 of them. So I've got a total of 2 minuses. So I need 2 pluses to balance it. So that means that I'm talking about iron 2. Right, that's the Fe2 plus. And the chlorine ion is called chloride. And because we're a binary compound, we still end with IDE anyway. So iron 2 chloride. All right. NH4,3PO4. So this piece right here, that's our ammonium. And this piece right here is our phosphate. Which looks like is our last choice here, ammonium phosphate. All right, so now we're getting into a new class of compound. So we've been talking all of these previous slides about ionic compounds entirely. Remembering, ionic compounds have a metal in their formula. Covalent compounds, or molecular compounds, are all nonmetals. Okay, so there are 2 types of covalent formulas. The molecular formula is what the atom or the molecule actually is. Okay, so in our example here, these 2 N's and these 4 H's, the molecular formula is the real-life molecule. Okay, that's how it exists out in the world. This other formula, the empirical formula, is the lowest multiple of the molecular formula. So if I've got a 2 and a 4 in my molecular formula, I can reduce that down to a 1 and a 2. But it still maintains the same ratio. It's still a 2-to-1 ratio, hydrogen to nitrogen. But the molecular formula is, like I said, the real-life molecule. That's how it actually is. So now here with question 20, we want to know how many valence electrons are represented in this Lewis structure. So there's 2 ways to think about this. Okay, the first way is you can say that each oxygen, we know from the periodic table that each oxygen has 6 valence electrons. So we would have a total of 12. Right? The other way to think about it is what's happening in the picture. So each one of these lines between those oxygens represents 2 electrons. And you can kind of picture it like an electron on each end of the line. Okay, and each of those oxygens has access to all of those electrons in those bonds. So the oxygen on the left has access to all those electrons. They're sharing them. Okay? The oxygen on the right also feels like it has all the electrons in those bonds because they're sharing them. Okay, so if I wanted to, I could look at the picture and count the electrons, knowing that there's 2 electrons in each one of those lines. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in this structure, does nitrogen atom fulfill the octet rule? So remember, the octet rule was 8 electrons. All right, so let's take a look at our drawing, and remembering that each one of those lines represents 2 electrons. Okay, and because of those lines, the nitrogen feels like it has access to all of the electrons in those bonds. So if we count the number of electrons that nitrogen has access to here, we have 2, 4, 6 in each of the bonds, or from the bonds, and then these 2 more lone pairs, these non-bonding pairs, makes 8. So yes, it fulfills the octet rule. So how many shared and unshared electrons, respectively, surround the nitrogen atom? So let's draw in our electrons on the lines, and the lines are shared electrons. Okay, so if we count the electrons in each of those lines, we have 6 that are shared. And then it has 2 that are unshared. 2 that belong only to nitrogen. So we have 6 and 2. 6 shared and 2 unshared. All right, so question 23, for this compound in the picture, C2H6 is the empirical formula, molecular formula, ionic formula, or Formula 1. Whoever wrote this slide had a sense of humor. So, remember, the molecular formula is how the molecule really is. Right, and the empirical formula is the lowest possible multiple of that molecular formula. So if the drawing here, that's the real life molecule. So we have 2 carbons and 6 hydrogens. So that's the real deal. So we're looking at the molecular formula for this one. It can't be the ionic formula because we have to have a metal in order for it to be ionic, and we don't have any metals in this drawing. And if it were the empirical formula, we would take the 2 and the 6 and reduce those to a 1 and a 3. It would say CH3. Okay, so moving on, molecular formula. Okay, before we get into this business, I'm going to go ahead and stop this particular video, and we'll come back with how to name covalent compounds.